And thanks, everyone. As Heather mentioned, we've been on a journey. We're still on that journey, so I'll share some of the details as we go through this, just to give you a little bit of view about why Shopify chose the path that we're on and how we're continuing to work to get there. So very specifically, if you don't know Shopify, you probably have already purchased from us, whether you know it or not. Millions and millions of merchants all around the world are actually by Shopify. We started as an e-commerce primarily to enable e-commerce for customers, whether they were established or new. Our CEO has a very strong belief that entrepreneurism and bringing new entrepreneurs to the world is really one of the key values that Shopify brings. But as Shopify has grown and evolved over the 20 plus years that it's existed, we've actually become very entrenched in a lot of commerce, more than just e-commerce. So pretty much across the commerce spectrum, even to the point where we're actually considering ourselves Commerce OS now, more so than just any other solution. This just means that it's more transactions in more places, which of course is really why we're talking about the scale. So where are we today? We are operating in 175 countries around the world. We have a fully global presence, 24/7 operations. We are deployed with traffic serving across every continent, probably in Antarctica too, but we don't have a data center there. Primarily our footprint today is all in GCP, but historically we've had our own data centers and we are always looking at other multi-cloud providers for other reasons, but the majority of our footprint today is GCP. We have billions of users, which really means that, as you start to think about what that means behind it from a relational database perspective, is tens, if not hundreds of billions of rows in every relational table. This doesn't scale very well in relational databases in general, and we'll talk about how we're trying to solve that problem both today and with Yugabyte into the future. We're also very high transactions. 20 billion QPS is not unusual for us. So we see that all the time right now. This is actually very, very high scale. Funnily enough, even our GCP account managers talk to us constantly about planning ahead for this kind of stuff because it doesn't happen organically. It's not out of the box. It's not for free. Karthik talked a little bit about that resiliency to cost curve, and I can tell you that that's certainly a very high end of that curve is where we start to run into these problems. But it's also a highly normalized relational model. Shopify was originally designed as a relational model. The application was built as a relational model. It's not going to be re-architected as a non-relational model anytime soon without a huge amount of effort. So we need to be able to map that relational model into this high transaction volume. Also, as we evolve from just e-commerce, where it was easily shardable, you could reason about sharding this by the merchant because the merchant had products and that they sold their products on their branded site. But as we evolve into these more agentic workloads and AI-driven workloads, that you see these merchants' desire to be present in these other places. And because they want to be present in those other places, we have less of a sharded infrastructure behind it because we have to present the entire view of all of Shopify's merchants across many of these places. So things are changing quite drastically, which is one of the reasons why we're on this evolution path. So how we grew to where we are today, we started with MySQL. MySQL, then you outgrow your single MySQL instance, so you shard it. When you shard it, you have to design your sharding strategy so that it works for application. We have tens of thousands of MySQL nodes today. And these, both master and replication. The replication is that kind of cost to resiliency curve that Karthik talked about, but it's petabytes and petabytes of storage. Not particularly efficient because a lot of replication, more replication than strictly necessary, because we're replicating for reasons that are not just the right reasons. We're replicating for resiliency reasons. We're replicating for read transaction reasons. We're replicating for read scale. We're also replicating for diurnal cycles that we can't actually manage to very effectively, so that the regional distribution is actually very high. Because it was all kind of developed from MySQL and our custom sharding, it also has a very bespoke management system behind this. How do we manage failovers? How do we manage replicas? How do we manage master promotions? If you're in a world like this, you find yourself on that resiliency curve where you're not necessarily in that non-single point of failure, because MySQL is a single point of failure by its definition. It doesn't actually have any quorum-based rights. This has led to a lot of application complexity over time. I mean, again, 20-year-old organization, 20-year-old application, but that application has leaked that complexity up into the application. And so, now to get to that point where we change the sharding model to support these new business needs has become an extremely important challenge to our system and how we actually think about that system moving forward. So we did start with some other MySQL-based solutions at one point. Vitess was something that we have actually deployed in production, but doesn't solve all the challenges, all the needs that we actually wanted to see. So what do we want to see? Ideally, we can get to a single global namespace. Ideally, I could make a single query across all the data that is the Shopify broad catalog of all personal data, merged in with catalog data, those billions of buyers, getting to that agentic solution, very similar to what Karthik demonstrated with his model. I also want the resiliency benefits of a multi-quorum right. I want to get out of this mode where we have these extremely sensitive writers that have to be babysat and have to be rapid application failovers to support very slow small downtimes, but the downtimes are still there. That gets us to a no single point of failure, ideally. Ideally, we don't actually have to suffer from any region outage or any failure mode where we have some maybe potential lag in the replication. These actually solve those problems. Flexible placement strategies was very important to us. Karthik briefly described it, but the notion that you can't actually have all the data replicated everywhere, it's just really expensive, not particularly aligned with compliance rules or data privacy rules. And ultimately, it's going to be driven more by where the reads are going to happen than where the writes happen. And so I'll talk a bit more about that in a minute. And ultimately, I can't change the application tomorrow. I mean, I can't go to Cassandra's model or Mongo model. I have to stick in this relational model. I have the 1,500 relational tables that are highly normalized. That application is not going to be rewritten tomorrow. So we evaluated a bunch of options. I mentioned Vitess earlier. I certainly looked at TiDB, which was also a MySQL-like model. We specifically did choose Yugabyte after looking at a bunch of these options. And the biggest reasons that we really chose it, we know Postgres is going to be a big move from MySQL, but Postgres is definitely where the ecosystem is going, where the investment is going. So Postgres as a model was very important to us. But yet we wanted that consensus model behind Postgres. I don't want the single point of failure that vanilla Postgres would give me. It would leave me in the same place I am with MySQL, even with the effort of the move from MySQL to Postgres. I want geo-partitioning. I want to be able to say, I want some of this data in this table to live here and some of this data in this table to live there. I don't want to be able to have the application have to shard anymore. I want the application actually to be independently unaware of these things, and I actually want the database to make sure it solves those things. And then one of the really important things from Shopify's perspective was this notion of sovereignty. So this is much more of a business need than a technical need. But as Shopify thinks about the next 20, 50, 100 years that we are in business, which hopefully I'll retire, but ultimately those years are going to be about how do we not have to re-architect again? How do we evolve within the context of the decisions we've made so that we can actually make those things come true? This comes down to some very important things on the business side. Certainly we evaluated Spanner because we're a GCP customer. So why not just use something like that? Ultimately, it came down to sovereignty, the ability to know that we can we can actually evolve with Yugabyte, the company, because it's an open source product. We actually license it on purpose because we don't want to just use it, but we want it to evolve, and we want other customers like yourselves, ideally, to make Yugabyte better so it's better for all of us. So where are we today? We probably operate one of the largest, if not the largest, Yugabyte clusters. The team would know better than I would, but certainly we're pushing the Yugabyte team to get to our scale that we actually want to get to. It is a globally stretched cluster. We're running it, certainly right now it's globally stretched primarily between the United States and Europe. We want to stretch it into Asia and Australia. Challenges exist, so we'll work through some of those latency challenges. I can describe some of those here in a moment. It is continentally scoped table spaces with regionally scoped table spaces. And this is to achieve latency goals as well as some of that data locality goals. So we actually want to make sure that we have the buyers, wherever the buyers live, their data stays where they are. The merchants, though, are wherever they live, so the data has to stay where they are. So today, most of our merchants are US and Europe. We're broad, we're absolutely expanding into Asia. And those kind of things are very important for us to make sure that they are locally scoped, but the buyers are global. Many of these merchants want to sell globally and make sure that the global data is actually present for them. Today, we're operating a relatively modest size cluster from a node count perspective, but it is 7,000 CPU cores. If you remember on my earlier slide, I mentioned we're at 20 million QPS on our MySQL cluster with thousands of nodes. This is one of the scale points that we're working with Yugabyte very carefully on right now, is to make sure that we can actually scale to something that approaches that point. Today, we're only pushing about 200 QPS into the Yugabyte cluster, and there's reasons for that. We can go into the details, but ultimately, it's still 1.4 petabytes of cluster. So it's a quite large cluster, like I said, one of the largest that is actually deployed, and we're working through the details now that actually make sure that we can reach that approximately 20x size that we think we need. But the biggest challenge for us actually hasn't been how do we scale the cluster, or how does the cluster get bigger? It actually turns out that the biggest challenge for us has been how do we have application engineers that are used to a single node writer database evolve to a distributed SQL database? Because a distributed SQL database just behaves differently. It feels different. The biggest challenges we have, things like when you think about your MySQL or your Postgres indexes, they're just a binary tree on a disk sitting in a single node. But here in Yugabyte, typically, well, you can do a single range index, but typically it's a hash range index, which, if you come from Cassandra or worlds like that, is very rational, makes a lot of sense. But when you're thinking about it from the pure relational database model, it's something the application engineers haven't had to think about before. And it has big impacts on the queries that they have to write against that data, as well as big impacts on the placement of that data. So making sure that our primary keys were appropriately designed for a hash range indexes is actually where we spent a fair bit of time over the last couple of months. The other one is fundamentally a latency understanding. Speed of light is speed of light. If you actually have a write quorum across a continent, it's going to be, even between US Central and US East on GCP, it's 35 milliseconds. You're not going to see a write quorum faster than 35 milliseconds round trip. It just isn't going to happen. But when you wrote to your MySQL database, it would happen in a millisecond because it was a single node in the data center. Of course, you're out of luck, but it's there. And so having our application teams actually come to grips with this new world and why it's valuable has been an interesting journey for us. And again, why does it matter to Shopify? Why are we going through this re-architecture? It's extremely important to us because this is the future. We absolutely know these are all publicly announced products, by the way, as none of this is proprietary. But we absolutely know that AI is going to drive the next interaction models. We are still a commerce company. It's moved from brick and mortar to e-commerce, but it's going to move from e-commerce to agentic commerce. We expect that. That changes the way all of this works, and it's what matters so much to us as we re-architect it. We actually launched with I think it was OpenAI, if I remember correctly, but we launched agentic shopping as a solution just recently, and so you see this now. You see this starting to appear where people can actually interact and check out directly within their LLM. But we don't know where the world's going to go, but we do know that the data beneath that has to be much more normalized to be able to provide that. And it has to scale on that trajectory that Karthik showed earlier, which means even though I do need 20x more nodes now in my cluster, I'm likely to need that to be even bigger and bigger and bigger. And there's real scaling challenges there. There's things that we're working very closely with the Yugabyte engineering teams on. We believe that between us and hopefully some of you, we can solve all those problems and actually achieve true global footprint that Shopify needs, but also that we hope you need as well. So some of the other little small things that we do need to work through, these are just kind of like, if I had a magic wand and Yugabyte supported these out of the box today, I've been working with the team. They know about them. We're working towards them. Read replicas are going to be important to us. We are not 50-50 in our query load. We certainly are read heavy, but write conscious. So the writes have to be very, very consistent, but the reads can be slightly more eventually consistent in many of the use cases, and especially the around the world use cases. So if a merchant is uploading their product catalog, it absolutely has to happen consistently, but it has to happen fast, reasonably fast. I mean, it can't be, like I said, the 35 milliseconds they're willing to accept, but they're not willing to accept the 200 milliseconds round trip between Singapore and US East, for example. And so I need a read replica in Singapore to support Asian buyers, but I need the write quorum in the United States. And then one of the other big ones that I'm still working through, Karthik mentioned data that exists in multiple places. Everything I'm talking about so far has been our transactional workloads, but we have very deep data pipelines, analytics pipelines, more petabytes of data that are driven by user activity that we need to get back into the system. So some of the things that he was speaking about earlier, we want to be able to start to integrate in ways that make sense for Shopify's business as well. Thank you. And
thank you, Brad. We actually have some questions for you.
Sounds great.
If you don't mind?
Absolutely.
All right. I got a highlighted question here. Given your scale, you probably get hit by outages, however small they may be. Is that the case? And how many and how often, if so, if you're allowed to say?
Sure. Yeah, so we have a status page like most SaaS businesses. You can absolutely track it. We aim to breach 4 nines of availability. We're not perfect. There are definitely a couple of times when we haven't. You'll see, I remember in recent history, and actually it lends very nicely to one of the things Karthik said. There's only kind of 2 failures. There's the actual equipment failed or it got slow. It turns out that more of our problems come from the it got slow. And usually that's a change that an engineer actually thought was a good change. It was a product value change, right? But it actually created a slow query. And if a slow query just builds up across the systems, what we see today typically would be we'd have to roll that back, go and redesign that query or the index or the whatever to solve that problem because we didn't see it until we were at scale. And those are some of the interesting ones, other than GCP's well-known incident from July, if you remember.
A friend of mine once said that if you haven't experienced downtime, you're not experienced yet. Yes. So the other one we have for you is, what replication factor does Shopify use?
Sure. So we actually aiming for different within Yugabyte, we're aiming for different replication factors for different table spaces. I mentioned the kind of 3 styles of table spaces. We have a global table space, which is RF7. We have a continental table space, which is RF5. And we have regional table spaces, which are RF3.
Nice. Thank you so much for this.
Absolutely.
Nice. Give him a round of applause, people.